This is SARS-CoV-2, the virus responsible for the global pandemic. It belongs to the family of coronaviruses, named for the distinctive crown-like spikes that cover their surfaces. These spikes give the viruses their unique appearance under a microscope. SARS-CoV-2 can cause COVID-19, a highly contagious viral infection that primarily attacks your throat and lungs, though it can affect other parts of the body as well. What actually happens inside your body when you contract the coronavirus? What exactly causes your body to develop pneumonia? How would a vaccine work to protect you? These are important questions that help us understand the disease and the efforts to fight it. The coronavirus must infect living cells in order to reproduce, because viruses are not truly alive on their own. Let's have a closer look inside the virus to see how it operates. Its genetic material, RNA in this case, contains all the information needed to make more copies of itself. A protective protein shell. The capsid safeguards the genetic material during its journey. Surrounding this shell is an outer envelope made of lipids, allowing the virus to infect cells by merging with the cell's membrane. Projecting outward are the famous spike proteins, which look like tiny crowns. Both influenza and coronavirus use their spikes like a key to unlock and enter a cell. Once inside, the virus hijacks the cell's internal machinery, repurposing it to build new viruses. When an infected person talks, coughs, or sneezes, tiny droplets carrying the virus are released into the air. These droplets may land in your mouth or nose and travel deeper into your lungs. Once inside, the virus contacts cells lining your throat, nose, or lungs. A spike protein inserts itself into a receptor molecule on the cell membrane, fitting like a key in a lock. This binding opens the way for entry. A typical flu virus travels toward the cell's nucleus. The coronavirus behaves differently. It doesn't need to enter the nucleus. Instead, it can directly access parts of the host cell called ribosomes, which are the protein-making factories of the cell. These ribosomes read the genetic information from the virus and begin producing viral proteins, including new spike proteins for the virus surface. Meanwhile, a packaging structure inside the cell carries these newly made spikes in small vesicles that move toward and merge with the cell's outer membrane. Gradually, all the necessary parts needed to create a complete new virus gathered just beneath the cell's membrane. Finally, a new virus particle begins to bud off from the cell's surface, ready to infect neighboring cells and continue the cycle of infection. Now that the virus is spreading throughout your body, how exactly can it lead to pneumonia? To understand this, we need to take a detailed look at the structure and function of your lungs. Each lung is divided into separate sections called lobes, 3 in the right lung and 2 in the left. Normally, when you breathe, air moves freely through your trachea or windpipe, then branches into large tubes called bronchi, followed by smaller tubes known as bronchioles, and finally reaches the tiny air sacs called alveoli. Airways and alveoli are remarkably flexible and springy, allowing them to expand and contract with every breath. When you inhale, each alveolus inflates like a small balloon to take in oxygen. When you exhale, the sacs deflate smoothly to release carbon dioxide. A network of tiny blood vessels called capillaries surrounds every alveolus. This close contact allows oxygen from the inhaled air to pass easily into your bloodstream through the capillaries, while carbon dioxide from your body moves in the opposite direction, into the alveoli so it can be expelled when you breathe out. Your airways have built-in defense mechanisms. They catch most germs and particles in the sticky mucus that lines your trachea, bronchi, and bronchioles. In a healthy body, millions of hair-like structures called cilia line these tubes and beat rhythmically to push the mucus and trapped germs upward and out of your airways, where you can expel them by coughing or swallowing. Additionally, specialized cells of your immune system stand ready to attack any viruses or bacteria that manage to slip past the mucus and cilia and reach the alveoli. However, during a coronavirus infection, the virus can multiply rapidly and overwhelm these defenses, especially if your immune system is not strong enough. The virus invades cells in the airways and alveoli, causing widespread inflammation as your immune system mounts a strong response to fight the multiplying invaders. This intense inflammation damages the delicate walls of the alveoli and causes them to fill with fluid and debris. As a result, oxygen has a much harder time passing into the bloodstream, leading to shortness of breath and low oxygen levels in the body. You might develop lobar pneumonia, where the infection and inflammation are concentrated in one lobe of the lung, or bronchopneumonia, which affects many scattered areas across both lungs. The symptoms of pneumonia can vary, but often include difficulty breathing, chest pain, persistent coughing, high fever accompanied by chills, confusion, especially in older adults, headache, muscle aches, and extreme fatigue. In more severe cases, it can lead to dangerous complications, such as respiratory failure. This happens when breathing becomes so labored and ineffective that a patient needs a mechanical ventilator to help push air into the lungs and maintain adequate oxygen levels. These life-saving machines became critically important during the pandemic, prompting medical device companies around the world to rapidly increase production to meet the surging demand. Whether or not you develop severe symptoms depends on many personal factors, including your age, overall health, and whether you have any pre-existing conditions, such as heart disease, diabetes, or weakened immunity. While the process sounds alarming and the potential consequences are serious, scientists and researchers responded with remarkable speed. The global push to develop an effective coronavirus vaccine moved forward at an unprecedented pace. Previous studies of related coronaviruses had led many experts to hope that people who recovered from a SARS-CoV-2 infection would gain some level of protection against reinfection for at least a period of time. However, this assumption required solid empirical evidence, and early studies showed mixed results, highlighting the need for careful research. 2. There are several innovative approaches being explored for potential vaccines against the coronavirus. The fundamental idea behind most vaccines is to safely introduce your immune system to a harmless version or component of the virus. You would receive a shot containing a weakened, inactivated, or genetically engineered version of the virus, or just its key spike protein. This vaccine exposure trains your body without causing actual infection. It stimulates a strong immune response so that, within a few weeks, your immune cells produce specific markers called antibodies. These antibodies are tailored to recognize and bind only to the coronavirus, particularly its spike protein. Once attached, the antibodies block the virus from latching onto your cells. Your immune system then receives signals to engulf and destroy the neutralized virus particles. Later, if you encounter the real, dangerous virus, your body will quickly recognize it, activate the same defense mechanisms, and eliminate the threat before it can cause serious illness. In short, the vaccine prepares and educates your immune system in advance. Ensuring that a vaccine is both safe and highly effective is one of the main reasons development takes time, even under emergency conditions. 2. It is truly a race against time during a raging pandemic. In normal circumstances, each phase of vaccine development and testing can take many months or even years to complete thoroughly. For comparison, the Ebola vaccine set a previous record by becoming available in about 5 years. For COVID-19, the ambitious goal was to achieve a safe and effective vaccine in a record-breaking 12 to 18 months. Through extraordinary international collaboration, accelerated trials, and massive funding. While all of this scientific work takes time to deliver results, there are simple but powerful actions everyone can take right now to slow the spread. Stay home whenever possible to protect yourself and especially the most vulnerable members of society. Practice social distancing, wear masks when required, and above all, don't forget to wash your hands thoroughly with soap and water for at least 20 seconds, repeating this as often as needed throughout the day. These everyday habits can make a huge difference in reducing transmission. Now, what would happen if you didn't follow these precautions for an entire year? Well, that's a story for another What If episode. 2. Hey there, Peter here. I'm recording this in my basement today as we continue to self-isolate and practice social distancing. I truly hope you are doing the same and staying safe. We want to extend a special thanks to Nucleus Medical Media for providing those excellent 3D animations that bring these complex biological processes to life so clearly. If you want to explore more scientifically accurate medical animations, be sure to visit their channel. There you can learn in depth about the human body, various conditions and illnesses, and the ways we can diagnose and treat them, too. At the end of the day, it's only through science, research, and collective responsibility that we are going to get through this challenging time. Stay safe, stay informed, and take care of one another, everyone.